Nestled amidst the rugged peaks of the Cascade Range, Mount St. Helens stands as a testament to both the raw beauty and untamed power of the natural world. Its snow-capped summit, often wreathed in wisps of steam, rises above a verdant landscape, a scene of tranquil beauty that belies the volcano's fiery heart. Yet beneath this serene facade lies a slumbering giant, capable of unleashing forces that can reshape the world in an instant. Recent increases in seismic activity serve as a stark reminder that Mount St. Helens is far from dormant, its fiery breath held in check by the delicate balance of Earth's tectonic plates. The world watched in awe and terror in 1980 as this seemingly tranquil giant awoke from its slumber. The eruption that followed served as a potent reminder of the immense power that lies dormant within our planet. The legacy of that eruption, etched into the very landscape surrounding the volcano, serves as a constant reminder of the forces that shape our world. Even today, decades after the cataclysmic eruption of 1980, Mount St. Helens continues to captivate our imaginations. Scientists and visitors alike flock to its slopes, drawn by the allure of its raw, untamed beauty, and the opportunity to witness firsthand the ongoing processes of geological rebirth. The mountain stands as a living laboratory, offering invaluable insights into the powerful forces that have shaped our planet over eons. But Mount St. Helens is not merely a spectacle, it is a force to be reckoned with. Located in southwestern Washington state, Mount St. Helens is a relatively young volcano, a mere 40,000 years old compared to the ancient origins of its Cascade Range neighbors. It is part of the Pacific Ring of Fire, a zone of intense volcanic and seismic activity that encircles the Pacific Ocean. This volatile region owes its existence to the relentless collision of tectonic plates, where the denser oceanic plate dives beneath the lighter continental plate, a process known as subduction. The history of Mount St. Helens is a tapestry woven with threads of fire, ash, and molten rock. Over millennia, the volcano has erupted numerous times, each eruption leaving its own unique mark on the surrounding landscape. The most powerful eruption in recorded history occurred on May 18, 1980. This eruption, triggered by a massive landslide, unleashed a lateral blast that flattened forests, melted glaciers, and sent a towering plume of ash and gas high into the atmosphere. The eruption claimed the lives of 57 people and caused widespread devastation. The 1980 eruption of Mount St. Helens left an indelible mark on the landscape, transforming the once conical peak into a horseshoe-shaped crater. The eruption's lateral blast, a phenomenon rarely witnessed in volcanic eruptions, ripped away a significant portion of the mountain's north face, leaving a gaping wound that exposes the volcano's inner workings. Within this crater, a new lava dome has been steadily growing since the eruption. This dome, formed by the slow extrusion of viscous lava, serves as a visible reminder of the volcano's ongoing activity. The dome's growth is episodic, punctuated by periods of quiescence and renewed activity, each phase carefully monitored by scientists for clues about the volcano's future behavior. The eruption's impact extended far beyond the immediate vicinity of the volcano. Pyroclastic flows, avalanches of superheated gas, ash, and rock raced down the mountain's slopes at speeds exceeding 600 miles per hour, incinerating everything in their path. These flows deposited vast quantities of volcanic debris, transforming lush valleys into desolate wastelands. The eruption also unleashed lahars, mudflows composed of volcanic ash, debris, and water. Can one volcano ignite another? The question of volcanic triggering, the idea that a volcanic eruption in one part of the world could trigger an eruption in another distant location, has long captivated the imagination. But could such a scenario play out in reality? Could the rumblings of Mount St. Helens, for example, awaken the slumbering giant that lies beneath Yellowstone National Park? Volcanic triggering, the idea that one eruption could trigger another, is a complex and debated topic among scientists. While there is evidence to suggest that volcanic activity can be influenced by external factors, such as earthquakes or even the weight of overlying ice sheets, The idea that one volcano can directly trigger an eruption in another remains largely speculative. The distance between Mount St. Helens and Yellowstone, over 500 miles, makes the possibility of direct triggering highly unlikely. These volcanoes belong to distinct geological systems with different magma sources and eruption mechanisms. Think of it like two houses with separate foundations. A tremor in one house is unlikely to shake the foundations of the other. Furthermore, the type and scale of eruptions that characterize Mount St. Helens and Yellowstone differ significantly. Yellowstone awakened, a hypothetical cataclysm. Imagine a world shrouded in ash, the sun a distant memory behind a veil of volcanic debris. Temperatures plummet, crops wither and die, and the very air we breathe becomes a choking hazard. This is not a scene from a dystopian novel, it is a glimpse into the potential aftermath of a Yellowstone supereruption. Yellowstone National Park, renowned for its geysers and hot springs, sits atop a massive caldera, a cauldron-like depression formed by a previous supereruption. Beneath this seemingly serene landscape lies a slumbering giant, a vast reservoir of molten rock capable of unleashing an eruption of unimaginable scale. A supereruption at Yellowstone would be a cataclysmic event, unleashing thousands of times more energy than the 1980 Mount St. Helens Eruption. The eruption would begin with a series of violent earthquakes, ripping apart the landscape and sending shockwaves across the globe. Molten rock and ash would be ejected high into the atmosphere, forming a massive eruption column that could reach heights of over 20 miles. Pyroclastic flows, racing outward from the caldera at hundreds of miles per hour, would incinerate everything in their path. These flows, a deadly mix of superheated gas, ash and rock, would engulf an area spanning hundreds of miles, obliterating entire cities and transforming the landscape into a desolate wasteland. The eruption's effects would extend far beyond the immediate blast zone. Vast quantities of ash would blanket much of North America, burying crops, collapsing roofs, and disrupting transportation networks. The global climate would be thrown into disarray.